So today we're going to talk about buffer solutions and how they work. So by definition, a buffer solution is a solution that would resist a pH change when you add a small amount of acid or base. So that's a key point there. When you only add a small amount of acid or base, if you keep on adding a lot of acid or base, the buffer solution is going to fail. It cannot control pH, it cannot resist the change in pH anymore when you keep on adding a lot. So basically, there are two kinds of buffer solutions. One is called an acid buffer. So that is when you mix a weak acid and its conjugate base. So it's very important that we need weak acids and its conjugate base. And the other kind is called an alkaline buffer, which is when you have a weak base and its conjugate acid. So if you're not sure about what those mean, so let's say that I have, let's say that this acid, so ethanoic acid. So this guy is reacting with water. And this is a weak acid. So I'm going to have a reversible reaction here. So this guy, technically, the acid is going to lose its proton to the water, and the water gets it back. So in the forward reaction, this is my acid. This is my acid, and this is the base, because this guy is donating the proton in the forward reaction, and this guy is accepting the proton in the forward reaction. But for the reverse one, this guy is the conjugate base, because this, in the reverse reaction, this guy is accepting the proton and becoming ethanoic acid. And this guy is donating the proton in the backward reaction. So this is the conjugate acid. So that's that, if you didn't know about that. So when I say that a buffer solution is a solution, let's talk about acid buffers first. So I need a weak acid. So this acid would work. This is a weak acid, I know that. And then I need its conjugate base, which is this one. So if I have the mixture of these two guys, I'm going to have a buffer solution. So let's see how that works. So if I have this guy, so this guy dissociates in a reversible reaction into this, right? So this guy dissociates like this. And when I have a conjugate base, so what's going to happen is I'm going to have basically a salt of it. Say I'm going to have CH3COO minus Na plus. So this is sodium ethanoate. This is a salt, right? So the reason that we have minus and plus here is that when we don't put anything and we write letters to represent elements, it means that they have covalent bond between them. But the bond here between this oxygen and this sodium is not covalent. It's ionic. That's why we need to put the minus and plus to show that this is ionic bond. So when you dissolve this salt in water, this is not reversible anymore. This dissociates completely into this and Na plus. So this is gone. This guy is gone. This guy is history. We don't have this anymore. This guy's gone. So this is a spectator ion. We don't worry about that. So basically, when we have these two guys in a beaker together, so I have lots of these guys. I have a huge amount of the ethanoate ion. I have a huge amount of this, and because they are in a beaker together, and you already have so much ethanoate ion, this equilibrium up here for the acid, is going to be the deprotonation of the acid is going to be suppressed, which means that As I already have such a high concentration of ethanoid ions, the equilibrium is going to shift to the left. So let me change the color. So the equilibrium shifts to the left. So this acid here is not dissociating anymore because you already have such a high concentration of ethanoid ion. So as this acid is not dissociating as much, so that means that is a very crucial point here. So that means that now we have huge, excuse me. So now we have huge amount of this guy and this guy. So these two are abundant in the beaker, in the solution, right? So now what happens is, as these two guys are predominant, so we could say that due to the presence of a high amount of ethanoid ion, this is suppressed. So these guys are also not there, right? Just like they are there, but in negligible amounts. We could ignore those. And this, we don't care about sodium ion here. So I have huge amount of the ethanoic acid, which is the weak acid, and I have huge amount of the ethanoid ion. So what happens is, now let's talk about the mode of action, right? So the mode of action of buffer, so the mode of action. So now, if you add H plus ions, so when you add remember this only works when you add a small amount of H plus ions. Small amount of H plus ions. Well, you could say H plus ions or, oh, I wrote acid. It's going to be ions. Let's just say that these are H plus, or just you could say hydroxonium ions. Those are the same thing, technically. What happens? So basically what happens is your, excuse me, so when you add, so this is, let's imagine the pink one, the pink H plus ions are the ones you have added. So what happens is then this guy reacts with the salt, the CH3COO minus ions. These guys react and they form CH3COO. So this is a covalent bond. This is not. This, they form the acid. So now when you add small amount, when you add a small amount of OH minus ions. So what happens then? So the thing that's going to happen is, let's see, this was in pink. Okay, so let me write this in different colors so that it's easy to see. So I'm going to erase this bit here. So when you add OH minus ions, what's going to happen is this acid will come into action. So my acid, the undissociated acid, okay, this guy comes in and reacts with the OH minus to form CH3C. Oh God, I always mix up the colors. So this guy forms CH3COO minus ion, the ethanoid ion, and it's gonna form water. So one of the H is from here, but the whole thing is this, right? So let's just write water like this so that you can see what's happening. So I think you already know what's happening. So this is the H from the acid, and then this is the OH. So this is water. So don't get confused with that. What the hell is this? Or what the heck is this? Excuse me. So that's that. So the idea is the amount of, as you have only added a small amount of H plus, the amount of acid you have produced is negligible compared to the huge amount of acid already present in the system. And the amount of ethanoid ion that you have used up is also negligible because you already have a huge amount of ethanoid ions coming from the salt, right? So that's why there is no pH change. And in this case, the amount of ethanoic acid that you're using up is negligible compared to the huge reservoir that you have up there. And the amount of ethanoid ion you produce is also negligible. This is negligible compared to the huge reservoir of ethanoid ion you have produced from the salt. So that's why there is no pH change. So at this point, you can think about how a buffer pH would work. So when you have a buffer pH, I'm just gonna write it down very briefly. So when you have a buffer that is alkaline or that is basic, alkaline probably will work. So you need a weak base. So we can see here that you need a weak base and its conjugate acid. So a weak base could be ammonia. So we need ammonia and we need its conjugate acid, which is NH4 plus. So we're gonna just bring in a salt here. So let's call it NH4Cl, right? Okay, so what would happen when you add H plus ions? So the idea is that I have huge amount of this salt and I have huge reservoir of the ammonia. So when you add H plus ions, what's going to happen is the ammonia is going to come into action. The huge reservoir of ammonia, only a small amount will come into action and they will form NH4 plus. So this NH4 plus is negligible, right? Because you already have a huge amount of NH4 plus coming from the salt. Because the salt dissociates, NH4Cl dissociates completely to form NH4 plus and Cl minus, right? So you already have a huge amount of that. So no change. And the amount of ammonia you have used here is also negligible. So what happens when you add OH minus ions? So when you add OH minus ions, so the ammonium ion come into play and they form ammonia and water. So again, the amount of ammonia you have produced is negligible and the amount of ammonium ion you have used is also negligible. So that's why there is no change in pH. That's how buffers work.